All right, this is my final networking report. Part one, I'm going to break it up into smaller videos. The first one, I'm going to cover the first three things on the checklist, so game demo, network management, and data queues. So first off, for the setup that I have, it's a one server, one client. I'm just going to switch back and forth like this if that's okay. So server says server at the top, and then client will be on this left menu window, saying client on the top. I have no physics on the client. It's completely commented out. The only things happening on the client are the input messages and then the prediction. So this is my quote-unquote best version. I have Dead Reckoning prediction. I'm not confident it's working perfectly because it's pretty rough, but my attempt at Dead Reckoning at least. So no physics on the client. I have some pretty bad network conditions. So right here, simulated loss 0.25, random latency 0.1, and Dead Reckoning. Yeah, I'm just gonna play it. So let me get the client going. Wait, okay. Server is right here on the right. Client is on the left. I'm starting the server first and the client. I have the time sync, so I have the time printed on the top left, so the time is synced. I'm going to start playing as green player 1 on the left, the client. So it's pretty jittery, especially with the, as you can see, there's kind of a big offset with the angle, but that's mostly because we're not predicting the angle, we're just predicting the position. So it's pretty smooth if he's just going in a straight line. He does bump off the screen quite a bit. I guess I'll talk more about Dead Reckoning later, but my window is only 3 pixels, so I don't know if that's supposed to be that bad. But I'm gonna fire some bullets as well to show that those work. And then I'm going to switch over to controlling player 2, which is the server on the right, and move him around. So I'm going to just hit the, if I can, try to hit that guy if I can. Maybe not. But yeah, so the server is smooth. The client is pretty bad. I don't know if I would consider it playable, but nothing crashes as far as I can tell, and at least the input is being processed even though it's really jittery. Oh, I guess I should lay some mines. So this is the server laying mines, and then I'm going to go to the client and lay some mines as well. So everything's pretty in sync as well. Cool. So that's the game demo with Dead Reckoning. Next, I'm going to move on to network management. So in my scenes, they each have, or in my different instances, they each have a network manager. So this is the client. The main scene has its own network manager right here, which is created at the beginning of the game. I have localhost. Since this is client, we have net client, and when you set it up, you create the client as a net client, as opposed to the server network manager, which has net server. And yeah, every frame of the game in both update loops, you have the network manager.process incoming, and you give it a reference to the message queue. So for the server, that's going to read from the Lidgren, message stream, anything that's in there. And if it finds something in there that has a message type data, then it's going to add it to the input queue as a message from the client. So going here, it deserializes the header and creates the appropriate message based on the header type. And then it adds that to the input queue. I'll go over more of the details of how I'm doing that later, but generally that's how you're reading in messages. On the client side, it's the exact same thing. So in the update loop, I'm doing network manager process incoming at the very beginning, and I have my message queue manager. If I get a message type data from Lidgren, then I do the message from server, which is exactly the same as message from client, just the name is different. I'm deserializing the header, then based on the header type, deserializing the rest of the message and adding it to the input queue. In terms of sending messages with Lidgren, it's a similar process. So when you say message to server, if we're on the client, we say message to server, we say send message via the network manager, and it just sends it. Here we used to just always do reliable ordered, but now the header contains its own delivery method in channel, so that you're sending it the right way, like this. And then server is the same thing. Server, network manager, send message. Yep. So that's basically network management and the integration with Lidgren. That's it. It all goes through the message queue manager. And then in terms of the data queues, I explained how I am putting things into the data queue. Also, every frame you're calling message queue process, so that's going to be process out and then process in. Process out, so I'm on the server right now, so I don't have anything to do with recording or playback. The server always acts the same. So process out, you loop through all of the messages in your output queue, and because it's the server, I have a switch statement based on the destination. So the server also acts as player 2, so you can either do it across the network, this will send it to the client, player 1. You can send it locally, so it'll just send it back into your own input queue. So right here, it's just adding to input queue instead of messaging to client. Or if it's a local and network, you add it to the input queue and you send it to the client. So this switch statement is just on the server, but I think it's necessary. So that's processing all of your output on the server. On the client, process out. Sorry, going back here, we do message queue in the update loop of the client. Process, we do process in, process out. But this depends on the game mode, so I'm going to talk more about that later, but the game mode is basically, are you normal mode, recording mode, or playback mode? So I'm going to go to normal mode right now. Process out, simple, you're just popping everything off of the queue and then sending it to the server. Process in, you are popping everything from the input queue and then executing it. So that happens every frame. And then in terms of adding things to your output queue, it just depends. So for client Dead Reckoning, all that you are adding to your output queue is the input messages. So right here I have input processing. So this is for player 1, because the client only controls player 1. Firing for player 1, laying a mine for player 1. And then you're building these messages and then adding them to the output queue if any of that input happens. So that's that. This is the Dead Reckoning stuff. Talk about later. And then on the server, for Dead Reckoning, you're just doing the prediction, and then yeah, I'm gonna talk about it later. But basically, you build output messages, and then they're sent out every frame, and then the input ones are processed. So I hope I covered everything about game demo, network management, and data queues. Next, I'm going to talk more about how I build my messages and how they're structured.